Leetcode problem 2336. So smallest number in infinite set. So for this problem, we are just giving such kind of infinite set. So it's going to be from numbers 1, 2, 3, 4, 5, etc. So yeah, it may be to n, and we don't know how big is this value. And even though it is said the num going to become 1 to 1000 and there are going to be 1000 calls. Maybe the maximum number is 1000. Yeah, but we don't need to control that because basically this is not what we are asked to do. Because we are giving this infinite numbers, so maybe this number is infinity, maybe 10 to the power of 9. Yeah, but we don't need to to confine it to 1000 because it is not necessary. Yeah, and basically we are giving this kind of a class a smallest infinite set, and we are also giving two methods, the pop smallest and add back. So the pop smallest means remove and return the smallest integer contained in the infinite set. Yeah, and the add back gonna add a positive number back into the infinite set. So if it is not already in the infinite set, yeah. So the add back means if it is not inside the infinite set, we're gonna add it back. So the idea is that how can we control on this infinite set? Basically, we cannot prepare a set like inside the set it's going to be 1000 numbers. Yeah, we cannot prepare it like that. So basically, we're gonna use a variable self.current from 0. So this means this gonna be the infinite set. So this means we're gonna set it from 0. It means every number, if it is more than self.current, it's going to be inside the infinite set. Yeah, if we directly use a variable, it's going to be much easier for us to solve the problem. Yeah. Now, as we have the pop smallest, because we're going to choose the smallest value, so this means we're going to use our priority queue. So let's just set a priority queue. Yeah. So now let's just try to do the pop smallest. So what are we going to do? First of all, we're going to update the current number, it's going to plus equal to 1, and then we're going to return self.current. So this means if we didn't do any add back operation, we just do a pop smallest. Yeah. So this is our stream. Yeah. So from the beginning, our current is 0. So this means all the numbers after this is 0. It must be inside the infinite set. So if we were to pop the smallest, what are we going to do? We're going to update the current. So current is going to plus 1. So the current is going to become 1. And we're going to return this 1. So this means all the numbers after this 1, 2, 3, 4, all the numbers after this 1, it's going to be inside the infinite set. So this is exactly what we are doing. But we're going to have this add back method. So this means if we were to add a number back, basically we need to put it somewhere. Yeah, but we cannot use this self.current to control it because we are not sure. So currently we are sure it's gonna add back a 1. But what if currently our self.current, so for example it is 5, and after 5 it's gonna be inside the infinite set 6, 7, or 8. Yeah. So currently what are we gonna do? If we were to add back a number, so for example the current number is 1 or 2. Yeah, we can directly add this number back. So for example, it is 1. But how can I add this one back? And where are we going to store this number? So this is going to be the problem. Yeah, definitely we cannot use the self.current to store because self.current is used to control the infinite set. Yeah, so this means for this number 1, we're going to store it from some other places. So basically we can use array, but we're going to use our priority queue. We're going to use a min heap. Because basically for each of time we're going to find the smallest number. So all those numbers like 1 or 2 it's going to be inside a min heap, and all those numbers are going to be less than and equal to 5. Yeah, because currently we can still add a 5 inside the heap. We can add 1 or we can add 5. It's going to be less than or equal to this number, and all the numbers after this 5 is going to be inside the infinite set. Yeah, currently we're going to use the self.current to represent. So if the number is bigger than self.current, definitely it's going to be inside the infinite set. But except that for all other numbers, it's gonna be stored in a min heap. Yeah. So this is exactly what we are doing. So now we want to check the self.min heap. So if there's something inside, so definitely we want to heap pop. Yeah. So we're gonna pop the self.min heap. So priority queue. So we're gonna directly pop it out, and we will not execute from here. Otherwise, if the min heap is empty, definitely we're gonna control it from the current. We're gonna update the current.value, self.current value, and then we're gonna return this value. Yeah. Now we're gonna do the add back operation. So for the add back, we need to check the number. So if this number is less than or equal to self.current, so basically we can add it back. Yeah. So we're gonna use heap push, and inside it's gonna be PQ, and with this number. But what if there's a duplicate? So this means even this number is less than or equal to self.current. If this number is more than self.current, basically it is inside of the infinite set. It is not necessary to add it back because it's already inside. If it's less than or equal, so this means we need to put it inside the priority queue. But we need to check if it is inside. So if and num not inside the self.pq, so we're gonna put it inside the priority queue. So this is all the operations. I hope I hope you understand all the operations about what we are doing. Yeah, as you can see, now it works. Although the speed is pretty fast, but for analyzing the time complexity, let's just analyze from here. So what about the heap pop? Yeah, so for the heap pop, it's going to be log n time, but it also depended on how big is the heap. Yeah, so for each of the operations, it's going to be log n time. But for here, what about this add back? So for this add back, so basically we want to check if this number is inside of the heap. This is going to be on time, so this is not so good. So this means we're going to use some other data structure to improve the time complexity, because basically we want to let the add back to be log n time. So we're going to use sorted list. So in Python, we can import it from the sorted containers. So we're going to import from sorted containers, we're going to import the sorted list. So currently, instead of a PQ, we're going to use the sorted list SL, and here going to be a sorted list. Yeah. Now we're going to use this sorted list to solve the problem, because it's going to be the same idea. Yeah. So if self.sl, so this means there's something inside. Basically we need to pop it out. So self.sl remove this number, and this number gonna be self.sl 0. So 0 gonna be the smallest number, and we're gonna remove it. And after that, we're gonna return this number. Yeah. So what about here? So if this number is less than or equal to, and this number is not in self.sorted list, I think we've changed everything, because the structure is same. We just changed the data structure from the priority queue to sorted list in Python. Here should be here I need to use the sorted list. Self.sl, I need to add this number. Yeah, now let me just submit it to prove that it works. Now as you can see, it works. But currently for this add back, the time complexity becomes log n, because we are going to check if this number not inside the self.sl, so this is going to be log n time. Yeah, but still there's a lot of coding. We still want to reduce the code, because basically here we are checking if this number is inside a sorted list. So what about we just check if this number, we just put this number inside a sorted set, because if we directly use a sorted set, we can save a lot of code. So now let's start to try to use a sorted set, because it's going to be much easier while we are using a sorted set to check everything. So here we're going to use a sorted set. So it's going to be self.s, it's going to be the sorted set. Now from here, if this number is less than self.current, so we're going to put it inside the sorted set. So self.s gonna add this number, because for a set there's no duplicate. We don't need to check if it is not inside the sorted list, because we are now using the unsorted set. So this means yeah, we can directly use the self.s.add this number. So what about the pop smallest? So now we're gonna check the sorted set. Yeah, so if it is not empty, we're gonna return. Yeah, we're gonna directly pop it. So self.s.pop. Where is it? It's gonna be at position 0. Yeah, because for a sorted set, we can pop out numbers, but we need to give index. So basically, it is at index 0 we're gonna pop out this number, and this number is gonna be the smallest. So this is exactly what we are doing. As you can see, we just deleted a lot of code for this sorted set. Now let me just run it and submit it to check if it works. As you can see, it works. Yeah, although the speed is it seems longer, but it doesn't matter, because for analyzing the time complexity, it's the same. So for here, it is log in time, and here it's also log in time, but we save a lot of code. I think that's all for it. Thank you for watching. See you next time.